So when a 12 agent chain makes a decision that turns out to be wrong, who is accountable? Rantej, after episode 1 went out, I had a few people message me separately with the same follow-up. You explain what agentic means, what the line is, initiation, fine, but how do you actually make multiple agents work together without it becoming chaos? Which is a fair question.
Yeah, and it's the right next question. One agent is hard enough, and 10 agents that talk to each other, delegate tasks, use shared tools, and sometimes disagree about what to do next. That's a different class of problem, and it's exactly where most teams hit a wall that they didn't even see coming.
And that's what today is, right? Welcome back to the Agentic Enterprise. I'm Lucia with Rantej, CEO and founder of Eligere Technologies. Let's get into it. So let's start with a picture. When you say multi-agent orchestration, what is actually happening? What does the system look like?
Think of it like a project team. You have an orchestrator, which is the equivalent of a project manager,
Mhm.
whose job is to understand the goal, break it into tasks, and assign those tasks to the right specialist agents. Each specialist agent has a defined role. For example, one might handle data retrieval, one does analysis on top of that data, one writes the output, and then one checks the entire output for compliance. Orchestra doesn't do the work itself, it coordinates. And when a specialist finishes a task, the result comes back to the orchestrator, which decides what happens next.
And those specialist agents, they're running simultaneously or one at a time.
It could be both. So, depending on what the workflow needs. So, some tasks are sequential. You can't do the analysis, for example, before you have the data. But others can run in parallel. A well designed orchestration layer knows the difference between the two and routes accordingly. That's part of where the efficiency gains come from. You're not waiting for each step to complete before the next one starts.
And who decides who's in charge? So if an agent disagrees with what the orchestrator is asking it to do.
So this is where the trust hierarchy becomes essential. And it's something you have to define before you write an orchestration code, not after. The trust hierarchy specifies which agents can instruct which other agents, what each agent is permitted to do without escalating, and what happens when an agent determines that a requested action falls outside the authorized scope. Without the written down and enforced architectural layer of trust hierarchy, you end up with agents that either escalate everything, which kills the efficiency gain, or act unilaterally in ways you don't sanction. So neither is acceptable in a regulated environment.
So what you're saying, the trust hierarchy is essentially the constitution of your agent system, correct?
So that's a good way to put it. And like any constitution, it needs to be written before the system is under pressure, not after something has gone wrong.
So you've seen orchestration fail in production, not in theory, but in actual customer deployments. What are the failure modes that enterprises don't see coming?
So I think there are three that come up repeatedly. The first is what we call context collapse. So each agent in a multi-agent system has its own context window, so its own working memory. So when the orchestrator passes a task to a specialist agent, it has to decide how much context to include. Too little context, and the agent makes decisions without understanding the goal it's serving. And too much context, and you hit token limits, latency spikes, and cost explosions. So teams underestimate that this constantly because it looks fine in a demo with clean small inputs, but at scale in production with real enterprise data, this kind of context collapse surfaces very fast.
Hmm. And the second?
The second is a cascade failure. In a single agent system, the failure is contained. There's just one agent. If it's broken, you know where the problem came from. But in a multi agent system, one agent's bad output becomes another agent's bad input. So, for example, in a compliance checking agent, system wherein one agent passes something that it shouldn't have, the downstream agent acts on that approval as if it was a valid compliance approval. So by the time the error surfaces, it's already been through three or four agents, and the original source is hard to trace back. So this is why lineage, knowing exactly which agent produced what output at what step, isn't just a nice to have. It's the only way to debug these kinds of multi-agentic systems, and the only way to satisfy an auditor who comes asking what went wrong.
Well, that's a governance architecture problem, not just a technology problem.
Exactly, and the third problem is goal drift, and this one's a little bit more subtle. So imagine you define a goal for your orchestrator, and let's say the goal was to process and approve low risk supplier invoices autonomously. Over a time, through normal operation, the orchestrator starts optimizing for what it's rewarded for, and in this case, it's rewarded for throughput and efficiency. So without tight constraints, it starts approving invoices that are technically within the rules but outside the spirit of what the business intended. So no single step went wrong in this case, but a cumulative, slow, gradual drift is what caused it. And because it happened gradually, there's no movement where anyone noticed the shift. You only see it in the quarterly review when someone asks why the approval rates went up by 20%.
So context collapse, cascade failure, goal drift. I think every enterprise team, should, about to deploy multi-agent, they need to write, those three on a whiteboard before they start, right? This seems like absolutely critical to bear in mind.
Yes, and also design a mitigation for each one of the above before you go anywhere near production, not after.
Great. So I want to bring in the liability question because it's the one I hear most often, right, from chief risk officers in European regulated institutions, for instance. So when a 12 agent chain makes a decision that turns out to be wrong, who is accountable? And the EU AI Act doesn't really fully resolve this. It assigns liability to the deployer of a high-risk system, but in a multi-agent architecture with an orchestrator, specialist agents, and possibly third-party tools, attribution is generally unclear. So how do you think about that?
So I think you have to design for accountability before you start worrying about liability. And accountability means for every consequential decision the system makes, there is a complete record of number one, which agent made it, number two, on the basis of what inputs, and number three, following what authorized logic. So if you have that, the liability question, while still legally complex, at least has a factual foundation to work from. If you don't have that record, you have nothing to give a regulator, a legal team, or a client who asks what happened and what went wrong.
And the human oversight. I mean, the EUA Act requires appropriate human oversight measures for high-risk systems, but it doesn't define what appropriate means. So what does meaningful human oversight look like when agents are making thousands of decisions a minute?
See, and I think this is one of the most misunderstood requirements in the AI Act right now. Meaningful oversight does not mean a human has to sign off every single action because that would eliminate the entire value of the agentic AI. It means humans define the boundaries, number one. Number two, monitor for drift. Number three, review exceptions. And number four, they have a credible ability to intervene and correct when required. So the oversight is in the system design and alert architecture, not in the approval loop for every individual decision. Getting that distinction right is the difference between governance model that works and one that's either a theater or a bottleneck.
And I'd add, if I may, from the conversation I'm having, that the enterprises getting this right are treating oversight as an operational discipline, not a compliance checkbox, right? So they have a named person responsible for each deployed agent system with a defined review cadence and escalation path. Obviously, it's not glamorous, but when the auditor comes, it's what they're looking for, right?
True, and operationalizing governance, it sounds obvious, but almost
Mm.
nobody does it before they really, really have to.
Okay, so 10 minutes. One concrete thing each. So, Rantej, for an enterprise team that's about to start a multi-agent project, what's the one thing they should do first that almost nobody does?
So I would say write the trust hierarchy before you write any
Mm.
code. So sit down with your technical lead, with your risk officer, or your legal team in the same room and answer three questions in writing. Number one, first, which agent actions require human approval before execution? Number two, which agent can instruct which other agent, and is there any action that requires a senior agent to intervene or authorize? And number three, what does an agent do when it encounters a situation outside its defined scope? Specifically, who does it escalate to? And what's the maximum time that the escalation can be open before system defaults to its safe fallback? So once you document that, sign it off, start building only after that.
Very useful. So, mine one piece of advice, comes obviously from the regulatory side. So, I would ask your AI vendor to show you how their platform handles cascade failure specifically, not in theory. You have to ask them, show me a real example of an agent producing bad output, and show me how the system detected it, contained it, and how the lineage log let you trace it back to the source. If they can walk you through that from a real deployment, you're talking to a platform that's been tested. If they start describing a hypothetical, then you're still in the demo phase, basically.
Absolutely. And that's a test that takes just about 15 minutes and tells you almost everything you need to know.
Mhm. All right, episode 2 done. Next time we go into data, and I don't mean data science, I mean the specific question of how agents access, move, and govern data across enterprise systems and jurisdictions. Integration is where most agent projects either succeed or quietly die. So look for episode 3 on integration is the moat. Thanks, Rantesh.
Thank you and looking forward to the next one. Bye, Lucia.
Bye.